Find the equation of the lines passing through the origin that divides the intercept of the line 3x plus 4y equals to 12 between the x's into 3 equal parts. Okay, let us begin. Let's try to understand the problem graphically first. So here we have the xy coordinate plane. Then we have three lines here. The blue line here, let's represent it as L1. So this is the line whose equation is given to us. That's 3x plus 4y equals to 12. Now, before coming to the other two lines, let's try to understand this line. So here we have 3x plus 4y equals to 12. That's given to us. Let's try to convert this equation into the intercept form. So we have 3x plus 4y equals to 12. All we have to do is divide 12 with 12. That's going to give us x over 4 added to y over 3 equals to 1. So this is the equation of the line L1 in the intercept form. Now, the advantage of writing any equation in the intercept form, we can immediately find out its x-intercept and the y-intercept. So here, the x-intercept, that is going to be denoted by the letter A, so that equals to 4. And the y-intercept of this line, the y-intercept of that same line, which is going to be denoted by the letter B in lowercase, is going to be 3. Now, what does it mean? This means that the line L1 is going to intersect the x-axis at a point A such that it is 4 units from the origin. So in other words, we can say that the coordinate of the point A, that's going to be 4, 0. And then the same line L1 is going to intersect the y-axis at B, meaning B is at a distance of 3 units from the origin. So coordinates of point B is going to be 0, 3. So using the given equation of the line 3x plus 4y equals to 12, we were successfully able to determine the coordinates of point A and B. Moving on. Now here we have two other lines. So here we have two lines. Let's call them the lines L2 and L3. Both of these two lines are going to pass through the origin having coordinates 0, 0. And let's say these two lines L2 and L3 are going to intersect the line L1 at 2 points. One intersects it at the point P and the other intersects it at the point Q. Our goal will be to determine the equation of the two lines L2 and L3 with the condition given here that P and Q, these points are such that they are going to trisect the line segment AB. Okay, so here let's try to understand this. So it's given in the problem that the 2 points P and Q trisects the line segment AB. In other words, here we have AP equals to PQ. This is going to be equals to QP. Now, using this information, we need to determine the equation of the two lines L2 and L3. So how should we do that? In order to find out the equation of those two lines, we're going to take the help of the 2-point form of a line. So let's quickly go through the 2-point form of a line. The 2-point form of a line requires us to at least have 2 points. 2 points, and when we join the 2 points, we're going to get a straight line. So let's say those 2 points are x1, y1 and x2, y2. So what we can do, we can use this to find out the equation of the line. So equation of the line, that's going to be given by y minus y1 equals to y2 minus y1 divided by x2 minus x1 whole multiplied to x minus x1. Fine. So that means in order to find out the equation of line L3 and L2, we need two coordinate values. So here our first goal will be to obtain the coordinates of point P. And once we have the coordinates of point P, we can use the other coordinate, which is the origin 0, 0 to obtain its equation. Similarly, to find out the equation of L2, we'll need to obtain the coordinates of point Q and then use the other coordinate, the origin, to find out its equation. Okay, so let us begin. So first what we'll do, we'll try to find out the coordinates of point P. Okay, let us begin. We're going to find out the coordinates of the point P. So coordinates of the point P. So here what we'll do, in order to find out the coordinates of point P, we're going to use the internal section formula. Clearly, P divide, we can say here that P divides AB internally. It is dividing it internally in the ratio 1:2. In essence, what we are saying here that AP divided by PB, this is the ratio 1:2. So using this information, our goal will be to determine the coordinates of point P. So let's do that. So clearly here AP, so this is 1, and then we have PB, so that's 2. To find out the coordinates of point P, or we'll start by first computing the x coordinate. So what we'll do, we'll take the value 1 here. So 1 is going to get multiplied to the x coordinate of point P. So the x coordinate of point B, that's 0. So we have 1 multiplied to 0, added to, we'll take 2. 2 is going to get multiplied to the x coordinate of point A. So that's 4. So we're 2 times 4 divided by the sum of the ratios, 1 added to 2. Then we're going to consider 1 and multiply it to the y coordinate of point B. So we have 1 multiplied to 3 added to 2 multiplied to y coordinate of point A. So that's 0 divided by 1 plus 2. Okay, so let's further simplify. So this gives us the coordinate of point P as 8/3, and we have 3/3, so that's simply going to be 1. So we have obtained the coordinates of point P as 8/3, 1. Now we are ready to find out the equation of line L3. So we can say equation of line L3. What is the equation? This is going to be given by, so here we need 2 points. So one of the point is the point P, 8/3, 1, and we need another point which is simply going to be the origin with coordinates 0, 0. So here we have y minus y1. So we can consider y1 to be the coordinates of the origin, the y coordinate of the origin, that's 0. This is going to be equals to y2. So y2 is simply 1 minus 0 divided by 8/3, so that's x2 minus x1 multiplied to x minus 0. Fine. So this is going to give us y equals to 3/8 multiplied to x. So we get 8y equals to 3x. Fine. So or you can say 3x minus 8y equals to 0. And clearly we know any equation which has the form x equals to k times y, it is going to be a straight line which passes through the origin. So this is going to be the equation of the line L3. Fine. Next task will be to obtain the coordinates of point Q so that we can find out the equation of line L2. Let's do that. So this time we will consider the point Q. So let's say point Q divides BA. The line segment BA in the ratio divides BA into ratio 1:2 internally. Dividing it in the ratio internally. In essence, we are saying here that the ratio BQ to that of QA, that's 1:2. So let's note it down. That's going to help us in computing the coordinates of point Q. Okay, so this means that the coordinates of Q is going to be, so we'll start by considering 1 and we're going to multiply it to the x coordinate of point A. So that's 4. So we're 1 times 4 added to 2 gets multiplied to the x coordinate of B. So we're 2 times 0 divided by the sum of the ratios 1 plus 2. Then let's find out the y coordinate. So we'll start with 1. 1 is going to get multiplied with the y coordinate of A. So we have 1 times 0 added to 2 times 3 whole divided by 1 plus 2. So this is going to give us 4/3, and we have 2 times 3, that's 6. 6 divided by 3, that's going to be simply 2. Right. So this is going to be the coordinate of point Q. Now we are ready to obtain its equation. So equation of line L2. So we're going to consider point Q having the coordinates 4/3, 2, and we're going to consider the origin 0, 0. So we have y minus 0 equals to 2 minus 0 divided by 4/3 minus 0 whole multiplied to x minus 0. So that's going to be equals to y is going to be equals to 3 over 2 multiplied to x, or in other words, we have 3x equals to 2y. So that's going to be the equation of line L2. So we have successfully obtained the equation of both of the two lines, L2 as well as L3. L3 came out to be 3x minus 8y equals to 0, and L2, that's 3x minus 2y. So both of these two lines are going to pass through the origin, and they're going to intersect the line 3x plus 4y equals to 12. It's only going to intersect, we have to be careful here, it's going to intersect the segment AB. It's not going to intersect the entire line, only the line segment AB.